Hello, my dear students. Welcome back to the lecture. So the next question is that where we do the lapping in the column. We understood for the beams, right? Now again, where do we do it for the column? Again, the answer remains the same. Wherever the bending moment is minimum, we're supposed to do the lapping there. So for columns, the lapping will be done at the center zone. That means the center zone in the sense, it's a middle zone in the column where the bending moment is less. Okay. So at center, the bending moment will be less. So we lap it here. So to put it in a better way, I'll explain you here once. So let us consider, I'm drawing one column here. So let us consider this is a column what I have. Okay. And what I'm going to do is, let us say over the beam, and we'll consider this to be a beam. Okay. A plinth beam. Okay. So this is a plinth beam what I have. Wait. This is a plinth beam what I have. Over the plinth beam, the column will come. And next what I have? Next I have a beam. This is my roof level beam. Okay. This is my roof level beam. This is my roof level beam. And oh, shall I do it in this way? It's okay. I'll do in this. See, this is my roof level beam. And over the roof level, what will happen? Your slab is going to come, isn't it? I'll draw the slab also. So slab, it will be hardly 150 thickness, thick slab, isn't it? So let me do. This is my slab thickness, isn't it? Good. Now, where you do the lapping of the column rebar. So always what happens is that we have a floor to floor height. What is floor to floor height? From the top of this plinth beam, okay, or from the top of this. Yeah. So okay, I'll redraw it again. Okay, there's some issue. I'll quickly redraw. Okay, let us say this is column, and then there is a beam. This is my plinth beam. Okay, and then I have a roof beam. This is my roof beam, and over the roof beam, what will happen? I mean, it is a slab portion. This much is my slab portion. Got it? Yeah. Now, where you are going to do the lapping for this particular column? So usually we have something called as floor to floor height, isn't it? So what is the floor height? From the top of the slab to the top of the another slab, we call it as a floor to floor height. Okay. So let us say from here to here, this is a floor to floor height. But my column will go only till the beam bottom. You can see this is my beam bottom. My column will be gone only up to here. And my column will start from the top of this. That is, either you can call it as a slab top, or you can call it as a, if here I have taken it as a beam, one and the same. Now, if I ask you to plot the bending moment diagram of a column, how will the bending moment diagram of a column look? I'll do it here. I'll do it here itself. Okay. Yeah, this will be nice. See, so the typical bending moment diagram of a column will be near the support. That this is a support, right? Here we have maximum bending moment. Here also we have maximum bending moment. Okay, and bending moment will become minimum in this portion. That is, this is how the bending moment variation will happen. Now you can see this one portion. So can I, yeah, can you see this middle portion? What has happened in the middle portion? Your bending moment is almost close to zero. See, this bending moment is maximum here near the bottom. Near the top of your bending moment is maximum. But by the time you come towards the center portion, you see how it is coming. It is coming here, coming. Finally, it has reached to zero. So this is that particular zone where the bending moment is minimum. And wherever the bending moment is minimum, we have to do the lapping. So where exactly this minimum bending moment is coming? So if this is a complete height of my column, exactly at the center it's coming. So I can call it as a center zone. So for columns, lapping will be done at the center zone. Very simple explanation. I've explained you the bending moment diagram. I can do one more thing. I'll quickly make it dark in color so that you get a better idea. Okay. Yeah. Okay. Maximum. And this portion it is. Yeah. Got it? This is how the bending moment variation is going to happen. All right. So this particular portion you have bending moment is 0, or we can say bending moment is minimum. There I'm going to do the lapping. Now with this understanding, I'll take you to few of the structural drawing. I'll take you to one of the drawing here. See, when you work as a site engineer, you get, or when you work as a site engineer, you get certain typical drawing. Okay. And they are going to mention where you have to do the lapping, where you should not do the lapping. Now, whatever concept I've explained you see the same application being done here also. Again, you can see this is the top of a floor and this is a bottom of a beam. Okay. This is beam bottom, this much portion, and this is top of the floor. Now you can see they have written something. You can see a kind of you see here in the middle portion you can see splice zone. Splice in the sense I told you about lapping. So you can do the lapping in the center portion. How exactly it is center? See, this is the height what I wanted from here. So this is the height what I have, isn't it? Now what is exactly at the center? Can I call this is my center of this is center portion? Exactly at the center, you can see the lapping has been done. See here, the lapping has been done and it's written here splice zone. Okay. Yeah, that's it. So that is the main thing what you're supposed to understand. If somebody asks you where you're going to do the lapping in the column, we are going to do the lapping in the column at the center. The reason behind that is the bending moment is minimum there, right? That is why we do. You can even plot the bending moment diagram, which I have taught you, and you can explain it in a more better way. But here, what has happened? Here we don't do the lapping. And here also we don't do the lapping. Why? Because there the bending moment is maximum. If you want, I'll quickly do it for you again. So here the bending moment is maximum. If this is a column, okay. In this portion, the bending moment will be maximum. Here also it is maximum. And if I try to draw a line there, right? So maximum, this is maximum. Here also it is maximum, but here it is almost close to zero, or you can call it as a minimum. So we do the lapping here, right? So I hope up to your concepts are clear. So that is why they have written all the things in this way. They have shown it, okay? They have shown it where you have to do. It's written splice zone, okay, right? I'll show you one more drawing for a better understanding. Yeah. Yeah. You can see it here also. It's not mentioned that you have to do, but actually the lapping will be done here. Okay. This is your height. Okay. And up to here, you don't do that. Up to here, you don't do that. In the middle portion, you do the lapping. I'll show you one more drawing. There it is clear. Yeah. Yeah. So you can see it here. You can see what is mentioned here. LD, that is this much lapping. I told you about the lap length, right? It has to be minimum development length. You can see it here. LD they have written. So LD in the sense it's a development length, but they have shown it for the lapping, right? So LD they have written minimum LD you have to do, and you can see where the lapping has been shown. The lapping has been shown here, right? And where was that exactly? See, this is a floor beam. This is the top of your beam. Okay, TOB stand for top of the beam. From the top of the beam to the bottom floor beam. No, this is your floor beam. Yeah, this is your floor beam. Okay. Now where is the center portion? If this is the height, where is your center portion? The center portion is somewhere here. This is my center portion, right? So I have to do the lapping in the center portion. Got it? Almost I'll do it here. Your center portion lies somewhere here. Okay. This much is your center portion. And you can see the lapping shown here. You can do the lapping here and you can do the lapping here. Okay, within the center you have to do the lapping. Got it? So that is how you are supposed to understand the structural drawings, and that is a concept of this one. And here also you can see again same thing you can see in this also. You can see the lapping has been shown here, the lapping has been shown here. Okay, why is that the lapping they have shown it here, here and here? So we know one more thing, at one particular junction more than 50% we cannot do the lapping. That means, okay, I'll explain that also. Let us say I have 8 diameter. I'll explain here itself. Let us say you have a column. You have 8 longitudinal rebar in a column. So all the 8 rebar, you are not going to do the lapping at this point only. All 8 you are not going to do. Out of that, that means the code says that 50% only you have to do. What is 50% of 8 number of bar? 4 number of bar. So 4 number of bar you are going to do the lapping here. Another 4 number of bar you are going to do the lapping here. So that is called a staggered lapping. You cannot lap at one single portion. One lap. Yeah, I'll put it here. See, this 4 rebar. Okay, these are my 4 rebar. This 4 rebar I'm going to lap at this portion. Another 4 rebar I'm going to lap at this portion. Got it? But it will lap in the center portion only, because when I say center, it's not a very small distance. If I have a, let us say, I'll put it in a better way. See, this is the height what I have. Consider this height to be 10 meter. 10 meter. Then what will be this height and this height? So you have to divide it by 3. Simple raw formula I'm giving. You divide it by 3. So this much portion, not divided by 3, divided by 4. H by 4. H by 4 comes out to be how much? 2.5. 2.5 meter. So from here 2.5 meter. Right? From here your 2.5 meter is gone. From here your 2.5 meter is gone. How much is left out? 2.5, 2.5. 5 is gone. Another 5 is left out. So that 5 meter is your middle portion. This middle portion what we have. This middle portion what you have, no? This is 5 meter. So within this 5 meter you have to do the lapping. So within 5 meter what I'm going to do? Few lapping I'm going to do here. 4 rebars lapping I'm going to do here. Another 4 rebars lapping I'm going to do it here. Got it? So this is a launch. This is a front view you're seeing. So that is how it looks. But practically 4 rebars will be lapped here. And after here certain distance will leave. Actually the code says it has to be 1.3 times the lap length. And then another 4 rebar I'm going to lap in this way. So in this way, what we can do, we are not lapping more than 50% of the bar. Even in the beam also same concept applies. In the beam, if I have 4 rebar, all the 4 bar I will not lap at one portion. 2 I'll lap here. Another 2 I'm going to take it to the other side. I'm going to lap it, right? So beam I forgot to explain you then. Again, you see, let us see if this is my beam. I'll delete everything. If this is my beam, okay. So I have 4 bar, okay. Then what I'm going to do, I'll lap 2 rebar here. 2 rebar I'm going to lap here. I'm going to lap here. Okay. And now let us say in the bottom portion also you are supposed to leave the bar. So next bar I won't stop here. Okay. You getting my point? I won't stop here and then I don't lap something like this. Why is that? Because again at one particular junction, see at this particular junction, both the bar you are lapped at the same portion. You should not do, only 50% has to be done. If there are 4 bars, 2 I'm going to lap it here. 2 in the sense this is not 2. See, you are seeing it from the front side. Behind this also there is another 2 bar. Okay. Yeah. So what I do, instead of adopting this method, I'll run this bar completely. So based on that, only you have to cut the rebar. Okay. On the side. I'll take it here. Okay. Now it is somewhere here. And also then, yeah, I'm going to lap it here. Now what has happened? I've done the lapping. Yes, I've done the lapping. Is it more than 50%? No, because in this portion I have lapped it here. This is for the beams, okay? In this portion I have lapped it here, whereas here I don't have any lapping. So more than 50% has not happened. Here I have done the lapping, whereas in this portion there is no lapping. So not more than 50% has happened. So this is how you do in the beam, right? I hope up to here your concepts are clear. We understood for the beam. We understood for the column. Column is very simple. At the center of a column, you have to lap it, done and dusted, right? Yeah. So we'll see you back in the next lecture. Thank you.